So in this video, what we want to do is show that x cubed plus x equals 7 has a solution somewhere between x is 1 and x is 2. And then after that, we're going to use this iterative formula where x naught equals 2, hence we've got a 2 here. Using this formula, we're going to use that formula 3 times to estimate a solution for x. So I'll show you how we get to this iterative formula from here as well, just before we have a go at this. First of all, let's look at this. So we want to show it's got a solution between 1 and 2. So what we can do is set this up as a function and bring the 7 across to the left hand side. So I've got f of x equals x cubed plus x minus 7. And that'll be our function. And then with x equals 1 and x equals 2, plug those into our function and hopefully we get a solution for that. That's going to go from negative to positive. So f of 1 equals 1 cubed plus 1 minus 7. So 1 plus 1 is 2 minus 7 is minus 5. So that's negative. So hopefully when we plug in 2 we get a positive. So f of 2 equals 2 cubed plus 2 minus 7. So that's 8 plus 2 is 10 minus 7. That gives me 3. And that's positive. So by virtue that this function here is continuous, as it's a polynomial function, and there must be a solution between x equals 1 and x equals 2 somewhere. So this graph will cross that x-axis somewhere there. By the virtue it's gone from a negative to a positive. So the graph will do something, as it's going from negative, that's x is 1, x is 2. The graph will be coming up there and do something like that. That's not necessarily how it is. It might be going this way, but it will do something like that. So that takes care of the first bit. Then we got this iterative formula. So this iterative formula is not just pulled out of thin air. We use the actual equation first to do it. So if I take this here, x cubed plus x equals 7. Now let's get this x over this side. So x cubed equals 7 minus x. And then take the cube root of both sides. So then x equals cube root 7 minus x. So then you'll notice that looks like that, very similar but in iterative terms. So with iterative terms here, x naught equals 2. So let's just put a line there. X naught equals 2. So now what is x1? So x1 would equal, so xn plus 1 equals cube root of 7 minus xn, which is going to be 0 in this case because that's n plus 1. So 7 minus x0, which is 2. So therefore x1, plug that into your calculator, is just a cube root of 5. So x1 equals 1.709975947 and so on. So that takes care of that. So now we've got to do this 3 times. Let's go for x2. So instead of keep writing each result, what you want to type in your calculator is cube root 7 minus the answer. And first of all, type 2 and then press EXE on your calculator, and that will then set the answer to 2 straight off. So press 2 on your calculator, then EXE, that will set answer as 2 and then go straight into there. That could just be answer. So x2. So I've got now x2 equals cube root 7 minus 1.709975 . So put that in your calculator. I'll get x2 equals 1.742418 and 02. So that's my second iteration taken care of. So now x3. So you've got this set up in your calculator. So now it should put that in as your answer. So now x3 is the cube root 7 minus 1.74241 . That should come out from your calculator as x cubed is 1.738 and 849 and 506 depending on how many digits your calculator goes to. So that tells me my solution after 3 iterations is approximately this. Now that looks legitimate because I've got 1.7099 here, 1.7424 here, so it's jumped up a little bit, and then it's just creeped down just a fraction here, much less than a jump from x1 to x2. So therefore my solution for x is going to be approximately 1.7389 to 4 decimal places. So that's where I think my solution is going to be approximately. Okay.